Chapter 2 is called Acute Angles and Right Triangles. And then we're going to actually cover 5 lessons for this. 2.1 is trig functions of acute angles. 2.2 is trig functions of non-acute angles. 2.3 will be approximations of trigonometric function values. 2.4 will be solutions and applications of right triangles. And 2.5 will be some word problems because it's called further applications of right triangles. So with this video, we're going to start with trigonometric functions of acute angles. So 2.1 homework has about 15 questions. So let's get started with this first one. The first one says, we have these values given here, and now we need to find the, match these questions with these function values. Again, I showed you this before, but I would like to explore again, how can I memorize these? And if you look at the angles here, we have the 45 degrees, 30 degrees, 60 degrees, 45 degrees. So these are all acute angles. If you still couldn't memorize them, so what you need to do is you will create a chart, and then you will place your 0 degree first, and then 30 degree next, 45 is in the middle, and then 60 is the next angle, and then we're going to finish this by 90s. The first line will be always the sine, and then this one will be the cosine. You can also do the other ones, but I'm just going to focus on these two. Again, just go ahead and place 0, 1, 2, 3, 4. And then take the square root of all these numbers and then divide them by 2. And then simplify. So when you simplify this, square root of 0 is 0. 0 divided by 2 is still a 0. So that means sine of 0 will be just a 0 here. So this one will just get me a 0. Next one is square root of 1. Square root of 1 is 1. And then when you divide it by 2, you will just get 1 over 2. So sine of 30 will be equal to 1 over 2. Sine of 45 is going to stay as root 2 over 2 because there is no way we can simplify this. For sine of 60, we're going to keep root 3 over 2 because there is no way we can simplify this. However, I can simplify the sine 90. Root 4 is 2. And if you divide 2 by 2, you just get 1. So therefore, sine 90 is equal to a 1. Since we get the sine values for these 5 key angles, it is very easy to get the cosine value for these key angles. All these 5 values, we're just going to write them in reverse order. So 1 will be the first number. Root 3 over 2 will be the second number. Root 2 over 2 is in the middle, stays in the middle. 1/2 moves to fourth position, and 0 comes to the last position. So now I have the sine of 30, sine of 45, sine of 60, sine of 90. And then the second line is the cosine of 0 is 1, cosine of 30 is root 3 over 2, cosine of 45 is root 2 over 2, cosine of 60 is a half, and cosine 90 is a 0. So when I look at this homework question, it asks me first locate sine of 45, which is root 2 over 2, so I will take it and drag it here. Cosine of 30 is root 3 over 2. I will move down here, tangent of 30. Now for 30, and I need the tangent of 30 now. I need tangent of 30 now. Tangent is always sine value of the angle divided by cosine value of the same angle. So sine of 30 is equal to a half, and cosine of 30 is equal to a root 3 over 2. Copy the first fraction, multiply it by the reciprocal of the other fraction. You will just get 1 over radical 3, but you have to rationalize the denominator, and you will get root 3 over 3 for tangent of 30. So I need root 3 over 3, and I need to drag it to tangent of 30. Secant of 60, secant is reciprocal of cosine. So we just need to locate the cosine of 60 first. Cosine of 60 is 1 over 2. Its reciprocal will be 2 over 1, simply just 2. So secant of 60 is just equal to a 2. Cosecant of 60 is reciprocal of sine 60. So here's the sine, and 60 is root 3 over 2. When I flip this over, I will get 2 over the 3. But when I rationalize the denominator, cosecant of 60 becomes 2 root 3 over 3. Then cotangent 45 is 45's tangent and cotangent value is the same number. And then there will be both equal to a 1. So I'm going to grab the 1 and I will drag it for cotangent 45. And this is going to answer number 1 for us. For question 2, the question we got is this. Let's just open them here. For question 2, we have a right triangle given, and then theta is placed. Its opposite side is 24, adjacent side is 7, and hypotenuse is 25. And they want us to find the all sine, cosine values. So for sine is its opposite side, which is 24, over the hypotenuse, and hypotenuse is equal to 25. Because we don't know about anything about the quadrant of the angle, we don't need to think about the signs. And oh, they told us that they're all acute angles. That means they're gonna be in the first quadrant, and third quadrant, everything is positive. For cosine of the angle, cosine is adjacent over hypotenuse, so the answer will be 7 over 25. Now for the tangent, we can use the triangle again. Tangent is opposite over adjacent, so it's going to be 24 over 7 is the tangent value for this question. Once we get these three functions, the rest three really depends on them. But it's not asking to us. Now it's the same lesson 2.1, but we have a different question. We have a triangle given us here, and they're telling that A value is 5, B value is 12, and then for angle B, we need to find the ratio. So angle B is over here. So for angle B, sine of angle B is its opposite divided by hypotenuse. So its opposite is B, and hypotenuse is C. So for angle B, its sine value will be calculated using B over C. And its cosine value will be calculated as using A over C, because its adjacent side is A and hypotenuse is still C. And its tangent value is opposite over adjacent, so we need B over A for the tangent of B. Now, the rest of the three trig functions are just reciprocal of this. Let's start from the opposite, the end. If tangent is B over A, cotangent will be A over B. If cosine is A over C, secant will be C over A. If sine is B over C, cosecant will be C over B, and this is how we're going to answer this question on the homework. Now, we have to keep working on this problem. Now, after the setup part, we're going to actually find the missing numerical values. If A is 5, B is 12, using the Pythagorean theorem, we're going to find that the hypotenuse must be 13. You can also think that 5, 12, 13 is a spatial triangle, and then the hypotenuse must be 13. Now, we will actually find the numerical values for sine of B. So this is our angle B. Its sine formula was B over C. So the B value is given in the problem as 12. And for the C value, we calculated as 13. So the sine will be 12 over 13 for angle B. The cosine is adjacent over hypotenuse, and adjacent side is given as 5. So cosine value will be 5 out of 13. And for tangent, for angle B, it's opposite over adjacent, so it's B over A. And B value is given as 12. And A value is given as 5. So this will be the tangent value for angle B. Now cosecant is reciprocal of sine, and reciprocal of sine will be 13 out of 12. Secant is reciprocal of cosine, so if you get the reciprocal of cosine, we're going to get 13 out of 5. And cotangent is reciprocal of tangent, so we're going to need 5 out of 12 because the tangent was 12 over 5. And this is how we handle question 3. So question 4 is the exact same style, so I'm going to let you guys explore this. A value is given as 9, B value is given 40. So using Pythagorean theorem, you can find the missing side C. So I'm going to just help you to set up this. You need all 3 sides for these 3 functions. So since A is given as 9, B is given as 40, and you need to find the C value, first you're going to find that C squared is always A squared plus B squared. So you want to solve for C. A value is given 9, so you need a 9 squared, and B value is given as 40, so you need a 40 squared. 9 squared is 81, 40 squared is 1600, and then when you add them up and then take the square root, this is 1681. This will be the C value. I don't know if this is something we can do without a calculator because I'm not very sure. I actually got help from the calculator because this was such a big number for my brain to take the square root. And the calculator told me that C value must be 41 if A is 9, B is 40. So you're going to plug in the C value for the triangle first. And then they will ask you to calculate the sine, cosine, and tangent. So for sine of angle B, you need opposite over hypotenuse. So for angle B, the opposite side is B, and B is 40 over 41. For cosine of B, you will need to calculate adjacent over hypotenuse. So adjacent side is 9 over 41. And tangent of B is opposite over adjacent, so 40 over 9 is the ratio you need to get. And then the other 3 functions are just reciprocal of this. So reciprocal of sine is cosecant B. You can just take the reciprocal of this fraction, 41 over 4. Secant of B is reciprocal of cosine, so it will become 41 over 9. And cotangent of B is the reciprocal of tangent, so you will get 9 over 40 for this question. Next one on the homework is, actually, I want to show you this one. It is still the same side, but this time you have to make sure that you understand what is given to you. This time A is given as 5, C is given as 9, and the missing side is B. So in order to solve for missing side, since the Pythagorean identity is A squared plus B squared is equal to C squared, A is given as 5, B is missing, and C value is 9. So that makes 25 plus B squared is equal to 81. So B squared is equal to 81 minus 25. So that makes our B squared to be equal to 56. And then B will be equal to square root of 56. And when I simplify this radical, it's 14 times 4 times 14. And 4 can go outside as 2, and radical 14 stays inside. So the B value will be 2 radical 14. Now, once we have all the sides in the triangle, sine value will be its opposite side over hypotenuse. So the opposite side is 2 radical 14, and hypotenuse is 9. Cosine is adjacent over hypotenuse, so adjacent side is just 5, and hypotenuse is 9. Now, tangent of angle B is opposite over adjacent, so we need B over A. So we got B value to be 2 radical 14. And A value is given as 5. Now we can just calculate the reciprocal of cosine. So reciprocal of cosine is here 9 over 5. And then for cosecant, I need to calculate the reciprocal of sine. So we will need 9 over 2 radical 14. But I'm not allowed to leave radical 14 in the denominator, so we have to multiply top and bottom by radical 14. That makes our numerator to be 9 and a radical 14. And then in the denominator, root 14 and root 14, that's going to give me 14. And then when I multiply them by 2, that will be a 28. So this will be the answer for cosecant of B. And cotangent is reciprocal of tangent. Because its tangent value was B over A, so this time I need A over B. So A is 5, and then B is 2 radical 14. But we're not allowed to leave radical 14 in the numerator, so we will multiply the top and bottom by radical 14. So here, after 5, I'm going to also have to copy a radical 14. And at the bottom, root 14 and root 14, that's a 28. When you multiply them by 2, that's how we're going to finalize this question. Now, next question says, we write secant 73 in terms of its cofunction. So if two angles are adding up to a 90 degrees, so if two angles are complementary, their cofunctions, they're going to have the same value. So secant of 73, the cofunction for secant is cosecant, which is CST. So, and then I just have to find its complementary angle, which will be 17 degree, because 73 and 17, they add up to a 90. So this is how I am going to answer this question. So secant of 73 will be always the same number as cosecant of 17. Another question with cofunctions. If I have secant of 12, this will be the always same number as cosecant of 90 minus 12, which will be a 78. So if I have tangent of 72, this will be always the same thing as cotangent of 90 minus 72, which makes 18 degrees. And then this is how I am going to answer this question. Find the exact value of sine of 30. We talked about this on the very beginning of the video. Sine of 30 is equal to 1 over 2, and this is a value you have to memorize. Secant of 30 is the reciprocal of cosine of 30. Cosine of 30 is root 3 over 2. So its reciprocal will be 2 over root 3. But then when you rationalize it, it will become 2 radical 3 over 3. This is how you're going to answer this question. Cosecant of 45 is the reciprocal of sine 45. And sine 45 is root 2 over 2. When you flip it over, it becomes 2 over root 2. And when you simplify it, it just becomes root 2. Cosine 45 is root 2 over 2. So we're just going to need a root 2 at the numerator and 2 in the denominator. Next question will be, tangent of 45 is equal to a 1. And sine of 60 is equal to a root 3 over 2. Tangent of 60. So sine 60 is root 3 over 2. Cosine 60 is 1 over 2. If I divide these two fractions, copy the first one, multiply it by the reciprocal of the other one. So it just gives me a root 3 as an answer for tangent 60. And then this finalized section 2.1.